Okay, so this one, or this question, deals with instantaneous rate of change. They've posed a question that a company builds calculators, or they manufacture calculators, and their cost is modeled by this function. Okay, so depending on the number of calculators they make, which is x, their total cost, you would plug x into this formula, and it would give the company what it would cost them to produce the calculators. The first question asks us, what does it cost for 100 calculators? Okay, we're going to solve that, and then we're going to relate it to the formula in B, so you can have an idea of what it is we're trying to talk about here. So the cost of 100 calculators. Well, all they're asking us in this question is literally to plug 100 into our formula. So we're looking at C at 100, which is equal to 10 times the root of 100 plus 1,000. The root of 100 is 10, so 10 by 10, whoops, plus 100, 1,000, I lied, is equal to 1,100, or 1,100. So the cost of producing 100 calculators is $1,100. The next question asks us, what is the rate of change in total cost at x equals 100? Okay, so let's refer back to our formula. We're looking for the rate of change at one specific point, which means we're looking for the instantaneous rate of change. So we're going to set up our limit formula of limit as h approaches 0, and our formula being the function of f plus a minus the function of a divided by h. Now, since a is 100, our f at a is essentially f at 100. We already know the answer to f at 100. Anyone know what it is? 1,100. F at 100 is essentially asking us the total cost. It's equal to $1,100. We've already figured that out. The cost of making 100 calculators is $1,100. So our f at a is already solved for us. We're now going to replace in our equation, and remember our equation was 10 root x plus 1,000. We're now going to replace the x in the equation, just the x itself, with our 100 plus h, okay, since our a is 100. So the limit of h as it approaches 0 is our formula. I got to go back up again here. There it is, which is 10 root 100 plus h minus 1,100. Divided by h. Okay? So, what we have here, again, is a radical function. In order to keep moving from here, we got to go over what we did in 1.1. We're going to have to rationalize. In this case, it's not a denominator, it's a numerator. So in order to rationalize the numerator, we take the same number, radical, we use the conjugate of it. So 100 times 100 plus h plus 1,100. Okay? Oh, did I leave something out here? Oh, I did leave something out of the formula. Sorry, I left out the plus 1,000. So before we rationalize this, I did leave plus 1,000 out. I apologize. What we're going to do here is we are going to simplify, then we're going to rationalize the numerator. So, since there is a plus 1,000, when we drop the brackets off, our limit of h approaches 0 is 10 times 100 plus h. And 1,000 minus 1,100 is just going to give us minus 100. Okay? So these two here give us a different constant. Then we get into rationalizing the numerator. When we rationalize the numerator here, same idea. 10 root 100 plus h plus 100 divided by the exact same thing below for this conjugate. 100 plus H plus 100. Okay. When we distribute this, the whole reason we did this is so we can just square what we had before. So, squared, 10 squared is going to give us what number? 10 times 10 is 100. Very vocal of you. When we multiply the root of 100 plus h, we're just actually going to get 100h. Okay? So we're multiplying again by 100 plus h. And 100 times 100 is going to give us 10,000. Okay? So that's when we multiplied our conjugate in. On the bottom, we're going to keep the h to the outside because remember our goal is to try to eliminate that h at the end of this equation. So we have 10 root 100 plus h plus 100. Okay? From there, we're going to simplify what we have on top. We are going to end up with 100 times 100, which will give us 10,000 again. So we'll have 10,000. This is when we use our distributive property. Plus 100h minus 10,000. So quickly looking at this, we know our 10,000s are going to cancel each other out. We're still going to be left with what was below. We're going to do two steps here. We know the 10,000s, positive and negative, are going to create a 0. We also know that what will only be left is 100h, so that means the h on the bottom and the h on the top are going to cancel each other out. So our limit as h approaches 0 is now 100 on the top, and once we've gotten rid of the h on the bottom, we're getting much closer to finishing up our answer in terms of simplified version. And we have 10 times the root of 100 plus h plus 100. Okay? From here, there's not much else we can do to simplify. And looking at this, it'll be easy for us to actually solve, what h is. Our limit is h as approaches 0, so this is where we're going to put our 0 in for our h. So our limit is going to continue down to this, 100 divided by 10 times root 100 plus 100. This will give us 100 over. Root 100 is 10, so that's 10 times 10 is 100. And 100 plus 100 is 200. So we have 100 over 200. Our answer is 1 over 2, or 0.5. So the rate of change when manufacturing the 100th calculator in terms of dollars would be 50 cents is what it will cost them.